Hello, my name is Nigel Hadley and I'm a product manager at Foundry, looking after the Nuke and Nuke Studio product lines. This presentation deals with colour and colour management in Nuke and looks at how we've dealt with the impact of new lower cost monitoring solutions. The years 2020 and 2021 will probably be remembered for something else, but what has affected the VFX industry has been the arrival of new lower price reference monitors, including the Dell UP3221. These new monitors are approximately less than 10% of the cost of a similar monitor from 5 years ago, so they are having an impact as more people can afford to use them in their VFX pipelines, and for the first time they can afford to have HDR monitoring on their desktop. This will have a big impact on the industry in the coming years. In the past, Nuke would have been run on a desktop screen, which was an SDR sRGB device. This meant that although the image being worked on was actually HDR, that extra dynamic range was not visible. In the Nuke 12 series, it was possible to monitor HDR images using SDI via HDMI from a dedicated video hardware card, like the Aja, Blackmagic or Bluefish. These would feed an SDI reference monitor, and by using an ST2084 PQ encoded output, it was possible to view the full dynamic range of the image. These cards, however, were fed the same image as the one on the desktop monitor, so they were not being independently colour managed, and the result would have meant the same image looked different on both the two screens. In the scenario here, the image in the GUI monitor would appear washed out. So for the Nuke 13 release, we changed things to better support monitors like the UP3021 and introduced a new colour managed viewer monitor out. We added a lot of other features to this new viewer monitor out, and I'm going to demonstrate these now in an overview of the feature. In the demonstration, you will see an emulation of a reference monitor in the lower right corner of the screen. This monitor is being fed by an Aja SDI device, and the signal flow being shown here is identical to the one that would be feeding the UP3221. The demonstration is mainly focused on the Nuke product, but the viewer monitor out in Nuke Studio and Hero are identical. Before going into the details, let's take a look at an overview of the new signal path in the Nuke 13 series. The big change here is that there are now two independent outputs from the Nuke computer. One of them, as before, is being used for the main GUI monitoring. Again, this is probably still an SDR sRGB monitor. Now, however, we can set the viewer transform for that monitor to be exactly what is needed, probably still sRGB. The second output is being fed via the SDI cards to the UP3221, and this is a completely independent output from the GUI viewer. The fact that it is independent means that it can be managed with totally separate controls. This means that for the first time, whilst the GUI on a standard sRGB screen is in sRGB display mode, the viewer monitor out can be set to ST2084 PQ and thus support HDR monitoring functionality. Coincidentally, at the same time, these hardware devices have also reduced significantly in price, again contributing to a new era of lower cost monitoring. So let's now look at the viewer monitor out in Nuke in more detail and look at some of the other features that it incorporates. The viewer monitor out can be accessed via a new workspace that has been added called Monitor Out. This will add a new Monitor Out strip below the main player controls in the GUI. From the Monitor Out strip, it's possible to access the new Monitor Out node. Most of the controls in the Monitor Out node and the strip are duplicated, but the node can show additional information whilst the strip just uses icons. There is a control for disabling and enabling the Monitor Out functionality. Currently, the external monitor is being fed by an Aja device. The output device is selected via a drop-down, and here you can see that we are using a Kona 4 card. Kona and Blackmagic cards have been updated for the 13.0 series release, and in the node there is a display of the SDK version and driver version being used. When controlling a hardware monitor out device, new controls have been added to make it easy to select the resolution and the frame rate required. New formats have also been added since the 12 series release as well. If you don't want to use a video output card, you could use an alternative floating window. This is a full screen display with no window dressings, which can be used on a second monitor and can be used to replace the conventional hardware SDI monitors. Like the Kona output, the floating window has an independent output transform, so we can select a different output transform for the one that is being used in the main viewer. When you switch back and forth to the Kona device, you can see that its output transform had been stored and is now being restored. Flipping back again changes it again to the floating window setting. Let's take a look at our signal path again. The important difference here is that we are now using Mac OS. Mac OS has support for EDR, so we can now simplify things considerably. We can use the floating window and send that directly via Thunderbolt to the UP3221, and this can now display the HDR image directly with the correct output transform in place. It would even be possible to display the GUI on a UP3221 to view HDR as well. Now we'll take a look at another very important feature in our support of monitor out devices like the Arja. In Nuke, there is an input process feature. A good use for this is for reformatting images. Imagine that I'm using a canvas that is a 2.5 or 6K image in the viewer. When I switch to the Arja device, which is limited to broadcast resolutions, the monitor will only be able to support HD or UHD, not the full canvas resolution. The result is that some of the image will be cropped. By adding a reformat node and enabling the input process, I can scale the image to the size that I want. The floating window will not need this functionality as it can handle any size of image. The floating window can also be resized by dragging any of its corners to increase or decrease the size of the image. Other useful controls that we have are a flip control. This can be used, for example, when using a ceiling mounted projector. There is an independent gamma gain control. If we adjust the gamma or gain controls in the viewer to aid the viewing process, we can decide if we want that function or not applied to the monitor out device. Another useful tool set when working on shots are the grid overlays, title safe, action safe. These can be output to the secondary monitor, either floating window or for the hardware device. So far we have looked at the use of the new viewer monitor out in Nuke. So how does it work in Nuke Studio and Hero? In this demo we are looking at Nuke Studio. The node graph has been supplemented with a timeline, but the viewer monitor out looks identical to Nuke with a node and a strip in the same place in the GUI. On the timeline here I have a comp effect. Double clicking on this takes me to the node graph. I can still see the same monitor out controls and can also see that the image in the UP3221 is the same. In Nuke I have now applied a simple effect, and on returning to the timeline I see the same image. Now in Studio I'm going to use the interactive mode to display the two images on the timeline in my viewer side by side. I can then enable the interactive mode on the monitor out strip and can now switch between buffer A, buffer B, and finally the interactive mode. This is a very powerful feature and allows artists to determine, for example, what the client might be seeing. So we can now have independently managed outputs from Nuke to the monitor. But critical to colour management is calibration of the monitor, and the UP3221 has a built-in colorimeter to do this. This automatic process will run through a sequence of colour swatches and perform a full calibration of the monitor, so now we know that the monitor is displaying our images correctly. So now, how do we get accurate colour managed images out of Nuke and onto the display? Well, the answer is that we use a colour management system called OCIO, and for Nuke 13 we have updated this to OCIO v2. OCIO is part of the VFX reference platform and is managed by the ASWF. Let's take a look at where OCIO is used in Nuke. First, we set up a project, and in the Colour Management tab, we will set OCIO. Next, we will set ACES 1.1 in the OCIO config. ACES is another ASWF software, and in this video, we will not be describing how ACES works. Next, we set the working space. This defines the colour space that Nuke will work in internally. All read inputs will be converted into this space. We will select Compositing Linear from the list of OCIO roles. This will set it to ACES CG. Now we move to our source material. As part of the script we are working on, we have imported a DPX sequence. Clicking on the file will open the read node of the file, showing the properties. There is a drop-down labelled Input Transform. This is the process that will be used to transform the file into ACES CG. It automatically defaults to Compositing Log. We are now nearly ready to start work. The final step is to set up our viewing devices to ensure that we are seeing the correct thing. My monitoring setup is the same as the one shown here. I'm using an sRGB monitor for my main GUI, and I'm sending an HDR image to the UP3221 via an Aja HDMI device. To set these up, I will first go to the viewer and set the view transform to sRGB ACES. This will use OCIO to transform the image from ACES CG into the sRGB needed for the display. Finally, I will go to my viewer monitor out. Select Kona 4 as my output device, and then select the output transform, which will be Rec 2020 ST2084 1000 nits. All the above settings are standard within the OCIO config. Anyone in the world can use the same settings on the same media and know that they will be getting the exact same result. In addition to these basic initial settings, we also have a number of extra OCIO nodes for utility colour work, which I will describe now. In these examples, for clarity, I have exaggerated the effect being applied. The first is OCI display. This can be seen here in the node graph. This is the exact same transform that was used when we set up the viewer earlier. The difference here is that it is a node that a user can place anywhere in their flow graph. Some users may decide to use this node instead of the viewer setting, which they will turn off. The input, as we see, is set to Scene Linear, ACES CG. Our display device is ACES, and our viewer transform is sRGB, exactly as we did earlier in the viewer. The node can be enabled and disabled using the D hotkey. Next up is the OCIO colour space node. This is used to transform from one colour space to another. In this example, we are going from ACES 2065 to Compositing Linear, ACES CG. These are just examples I'm using to show what the node could be used for. Next is the OCIO CDL transform. This is used to load a CDL file. These will normally have been supplied by a Daly's grading platform. They apply slope, offset, power, colour grading values to the file, giving a basic guide to a look that a DIT has established on set. Again, just for example, we can enable, disable to see the effect. Next is the OCIO file transform. This is used for loading LUTs, again a form of colour manipulation that can be used in different workflow scenarios. LUTs are extremely common throughout the industry, so having a standardised way of reading them is very important. Included in the node is a direction log, which allows us to invert a LUT. Next is the OCIO log convert. This is designed to be used to convert log material. Almost all film scans are scanned to log colour space, and this tool is used to convert into linear colour space. The node has a knob to set the direction of the colour space transform, log to lin or lin to log. Finally, we have OCIO Look Transform. A look is a named colour transform intended to modify the look of an image in a creative manner. This is as opposed to a colour space definition, which tends to be technically mathematically defined. In the node, again, there is a direction control allowing forward or inverse viewing of the look. These OCIO nodes are also all present in Nuke Studio as soft effects, as can be seen here. One of the big features of OCIO V2 is it provides a new GPU implementation, which provides perceptually identical CPU and GPU output. This means that we now have a consistent viewing experience between Nuke and Nuke Studio. Here, we have added a couple of OCIO soft effects to our shot on the timeline. We can also copy and paste directly from the node graph here over to the timeline here. We have now pasted the OCIO Look Transform as a soft effect, and you can see that it works exactly the same as it did in Nuke. Finally, how does this all work together in practice? Let's get Jessie Burgess, a member of our content creation team, to give us an overview of how Nuke Studio, Hero and Nuke work together in practice.
Thanks, Nigel. So now I'm going to show you multiple workflows where you can use Nuke Studio, Hero or Hero Player. First, let's look at how we can use Nuke along with Hero Player. As an artist which is working in OCIO and Nuke, at some point we'll want to create a flipbook and have these settings carried across with it. Instead of using Nuke's inbuilt flipbook, we can use Hero Player and its GPU-based viewer as a flipbook and carry across the colour profile you've been working in, making sure we are continuing to view the correct image. Hero Player will launch once processed and start playing back. You are able to move around the viewer timeline and viewer without losing the cache while inspecting your shot. As you carry on making adjustments to the comp back in Nuke and begin to create new flipbooks, which can be sent to the same Hero Player session, carrying across the correct colour profile. The viewer in Hero Player will be set to the same as it was in Nuke. Hero Player is very artist friendly. We can compare our different flipbook versions directly in the viewer, and you can also view individual channels in the viewer if you are working with multi-layer EXRs. We can also use the timeline by dragging and dropping our multiple shots and version onto it to compare and check for continuity. There are multiple wipe modes available in the viewer, for example the wipe mode, or horizontal side by side. With Hero Player, you can also connect with the studio's asset manager and pull shots directly to the timeline. So we can load in all of the shots that were being worked on and have access to all of the versions for each shot. And this works whether you are using Shotgun, F-Track or a custom asset manager as we're doing here. Then not only can we bring shots into our session, but we can also push the changes back to the asset manager from the timeline. So we can use this both ways. The next thing I want to show you is how as an artist we can connect to other timelines using a sync session. This is a great way to connect for a team review session or even a casual review between an artist and a supervisor. You have an unlimited amount of users that can connect to a sync session. And a key point here is with sync, there is no need to prep any quick times, so we can go straight into our review. Also, users connected with different monitors that are set up with the correct viewing profile for their particular screens will still be seeing the correct same image as everyone else connected. At this point, the supervisor is using Nuke Studio and the artist Hero Player, bringing us onto a unified timeline. During the sync session, the supervisor can add annotations to the shot, frame or sequence, and this is whether they are using the paint tool or text tool to help visualize the changes that need to be done. And all of these annotations will appear live for everyone connected. This works both ways. The artist can participate and create annotations the same way as a supervisor would, and visualize areas in the shot, keeping both artists and supervisors on the same page. And from the sync session, artists can open their comp directly from the timeline in a new Nuke session where they can address those notes and start making the changes. Everything I have shown you so far is also available in Nuke Studio, but now let's jump into the role of a supervisor and look at some specific tasks. First, let's look at how we can do Conform and Playback in Nuke Studio. You can import an EDL, XML or AAF directly onto the timeline, and this will come in offline, but we can use the Conform workspace and the spreadsheet to match the media. At this point, you can set the Conform options for your project, and once complete, all of the media should be online. Once online, you can set the input transform coming from OCIO v2 on each of the read nodes. You can also set the reference media, and Nuke Studio will automatically build out a reference track for you, and this is including any audio. You can also copy cuts from one or more tracks to another track. For this case, we might want to send the reference clip to our artists as well, so we can copy the cuts from the edit onto the reference track, which can then be distributed. When it comes to playback in Nuke Studio, we'd first be inspecting the edit using the same GPU viewer as we have in Hero Player. This gives us a stable playback engine capable of high resolution footage. For heavier areas of the sequence with many clips, blend tracks and effects, you can utilise the timeline disk caching available in Nuke Studio. As the area selected caches to disk, you'll see an orange line appear in the viewer timeline indicating which areas have been cached to disk, which once complete can be played back smoothly. The next tool we have in Nuke Studio I want to show you are the different ways you can add soft effects to the timeline. So continuing on from what Nigel showed you with the OCIO soft effects, we also have a range of different effects you can apply. There are multiple ways you can add soft effects. First, we can add soft effects to individual clips. So by adding a soft effect to a clip, for example we have a grade here, when you make changes to the version of the clip, that soft effect will be carried across to each version. You can also add soft effects to the entire sequence by adding a soft effect to an empty track. And these can be edited, so we can choose what areas of the sequence we want affected and which we don't. And finally, we can add soft effects to individual versions. So here we are comparing version 11 and version 12 of this clip, where you can see version 11 has a blue line on it, showing that it has a soft effect on it. This can be quite useful. For example, if a LUT changes throughout the show, you could have a soft effect associated with a particular version. Following on from soft effects, we also have the ability to add tags and inject metadata into our shots. You can pass metadata through tags and have these in line with your asset manager using the different statuses, or even have custom tags that represent artists so you can visually see who's working on which shot. We can add tags to each clip and add any extra information we want to add to that. We can also add tags to individual frames across a sequence from the viewer, and this is great for when you're having a review session. You could tag certain frames in advance, then jump between them to hone in on specific areas during your review session. As well as adding tags to the sequence, we can also filter shots from our tags. We can do this to then isolate only the approved shots, for example, to then build out a timeline of those specific shots, which is great to have in advance for a team review as well. And this could be done for each artist working on the project. This leads us into how we can use Nuke Studio to manage our shots and sequences. As a supervisor, you can build tracks automatically on the timeline from the renders coming in from other departments, for example, the 3D or effects department. So as other departments complete their work, you can procedurally add it to the timeline and be able to manage the multiple versions of each of the elements as they are completed. As elements are added to the timeline, we can use blend tracks to start getting an idea on how the different elements from each department are building the shot. We can also create Nuke comps directly on the timeline, bringing all of the elements from the different departments into the comp to be ready for your artists. Comps created on the timeline will carry over the colour profile between Nuke Studio and Nuke, so you know you and your artists will be viewing the same image. You also have the ability to then do quality checks of each of the elements in the node graph before handing over to your artists. And any annotations or notes given in Nuke Studio on the shot will be carried across into the node graph through a pre-comp node. A great workflow to have is sequences based on each of your artists, which we can create from the tags as mentioned earlier. This way you can have a clean visual way to view each of your artists' work, and you have access to the comps, which, like I just mentioned, has access to all of the versions of annotations or notes given to your artist on that shot, which you can then cycle through. You could have the handles laid out on your artist sequence, and then on the main sequence the clips would be trimmed as well. There are times when we need multiple versions of your sequence which has different timings or language, for example the sign here. With Nuke Studio you have the ability to unlink your versions of a clip or comp, and by breaking the version link on our other delivery sequence we can connect it to another version of our shot where the language has changed. You can also create snapshots of your timeline. This is extremely useful when experimenting or building up the sequence, as well as being used as reference when reconforming. With snapshots, you are able to go back to certain states of your timeline, so you're able to compare between the different edits as your sequence was built up. As well as all of the tools and workflows I've shown you inside of Nuke Studio, you also have access to all of the tools available in Nuke X. By having Nuke X and its node graph directly in Nuke Studio, this means you have access to all of the nodes of Nuke X at your fingertips, for example the Smart Vector and Camera Tracker, as well as access to the new machine learning tools, for example the Copycat and the Inference node. By having these at your fingertips, you can start creating your own machine learning models for effects to then share the trained data with your artists to use on their own shots. Finally, you can manage the distribution of your project's elements from Nuke Studio. We have multiple ways you can export from Nuke Studio. From the export options, we can distribute the whole sequence for a client review session, and we can also export an XML to send our sequence to another editorial package. We can transcode shots from our timeline with specific settings, and there are multiple default presets that come with Nuke Studio that you can use. Or you can create your own project-specific export presets, which can be customized from the file type to the output transform through OCIO v2. We can also batch create Nuke scripts and customize project settings and write notes, so artists don't need to find footage or worry about where their comp is being written to. We can also add any additional nodes to be generated with the script. And we can set up the right nodes for all scripts, for example, so that the location, the file type, and any channels exported are correct. The export preset can be customized by using the different tokens available for the file name and the folder structure. We can export or create comps for all tracks in the sequence, or filter which tracks we want for export. We can also filter our export from any tags in the project. For example, if we only wanted to export the final or approved shots. Finally, we can also adjust the handle settings, and we can set if we want the export to be local with Nuke Studio's frame server or be sent to a render farm. Finally, here you can see with Nuke Studio, Hero and Hero Player, everyone involved can link back to a unified timeline and collaboratively work together.
Thanks, Jessie. I hope that helps you understand how colour and colour management work in Nuke and Nuke Studio. If you'd like to learn more, please visit our website where you can access our learning page. And with that, I'll say goodbye, stay safe and have a great day.